Hello, this is the first Flashback Friday from February, February number 1 for second years, and it starts with a trigonometric proof question. With these kind of questions, you always need to decide whether you want to start with the left-hand side and then end up with the right-hand side, or start with the right-hand side and end up with the left-hand side. I, as a general rule, I would start with the left-hand side unless there's a very good reason not to. Unless you spot something that's easy to simplify on the right-hand side, I would just start by writing down the left-hand side. And then we're going to need to do some kind of algebra, maybe use some trig identities, do some simplifying to end up with the right-hand side. So starting on the left-hand side, I wouldn't don't write down the right hand side. If you want to write down the right hand side, then maybe write it right at the end here, because this is where you need to end up. You're not starting with this. This is where you need to end up in your proof. Okay, and if you can end up there, then you know you're finished. Okay, but start with writing down the left hand side, and I think we're going to need to expand the brackets here. So that would be cot squared plus 2 cot theta sorry, I missed out the theta there. 2 cot theta cosec theta, and then plus cosec squared theta. Now it's not obvious what to do next, so it's always a good idea to take a look at where you need to end up, and we need to end up with just coses. So we don't want any cots or cosecs in our final answer. So I think a good idea would just be to replace all of these cots and cosecs with sines and coses. So cot is cos theta over sine theta. So cot squared is going to be cos squared over sine squared. Let's do the same for this. Cot theta, that would be cos theta over sine theta, and then we times that by 1 over sine theta plus 1 over sine squared theta. Okay, now if you look at this, the denominator here is going to be sine squared theta. So we can write that as a single fraction now, all over sine squared theta. The numerator is going to be cos squared theta plus 2 cos theta plus 1. Now it's not immediately obvious how to go from where we are now to this answer down here. So what you could do is think about maybe factorizing the numerator or the denominator. But something we do need to know, something that would probably help is to get rid of this sine squared, because our final answer hasn't got any sines in. Okay, so I would suggest replacing this sine squared with a 1 minus cos squared. So if we do that, we've got cos theta plus, the numerator is going to stay as it is, and this is going to be 1 minus cos squared theta. Now looking at where we need to finish, you might notice that this denominator here is the difference of 2 squares. So I think that's going to help us out, and we're going to be able to factorize that. We're also going to be able to factorize the numerator quite easily. It's a quadratic in cos theta. So let's factorize both of these. I'm running out of a bit of space here, so I really want to do it. In this gap here, but I've not got room, so I'm going to move it over here. And if we factorize the numerator, that would give us 1 plus cos theta multiplied by another one. Okay, that is, the numerator is 1 plus cos theta all squared. Now the denominator is the difference of two squares, so that's even easier to factorize. It's 1 plus cos theta times by 1 minus cos theta. And as you can see, that's very helpful, because now the 1 plus cos thetas are going to cancel. So we can cancel this with this. And then we have finished the left hand side. We start with the left hand side here, and we finished with the right hand side. So we've proved that question is correct.